In this video today, we're going to learn how to extract structured information from annual reports or 10Ks and how to summarize them using large language models and Python. So let us get right into it. Now, I want to get started by giving you a brief demonstration of the final results so you know what you're getting yourself into with this tutorial. We're going to build a Python script that extracts information from 10K reports, from annual reports in a structured way, and this can be completely customized. Now, for those of you who don't know what 10K reports are, these are very long documents provided by companies, by public companies, targeting investors and informing them about the state of the company. So financial statements, balance sheets, risk factors, officers, numbers of employees, a lot of information is in here. For example, here the Meta 10K report has 150 pages. I also have, here's an example, the NVIDIA 10K report for 2025, which is a little bit more stylish, but the basic idea is the same. When you scroll down, you're going to see lots of tables, lots of text, lots of numbers, and all of this is interesting information for investors. Now, serious investors will most likely read through the whole document anyways, but maybe you're looking for new companies to invest in and you have to scan through a bunch of different annual reports. You just want to have some key information. You don't want to seek it out yourself because every report looks slightly differently. You don't want to go and look for specific metrics. You don't want to scan the document from top to bottom. You also don't want to pay someone to do it for you. You want to summarize it easily in Python. So what you can do here is you can define a custom data model. We're going to talk about this in the tutorial. And then you can just run a Python script, in my case, main.py. And this Python script now will extract information. In this case, now I'm targeting the Meta 10K report. It will extract information in a structured way that I have defined and that I consider to be important. I have a very basic data model here. I'm just extracting some key financial metrics and then some descriptions and risk factors. But you can customize this fully. You can make this to be whatever you want it to be, and then you're going to get a filled data model that you can see here now in the command line. Not the best way to display it. So what I also do here is I export a PDF document with all the information summarized. So again, this is a very basic document in my case. You can customize this and extend it however you want, but basically I have here name of the company, the identifier, the year end, the filing date, some financial information, revenue, net income, and so on, the description of the business, risk factors listed as bullet points, and also the management discussion and analysis. So that is a very basic report, and in this video today we're going to learn how you can do this yourself, how you can customize the data model and get for any company, for any 10K report, such a document that summarizes what is important to you. So let us get started now. There's a couple of things that we need to set up before we can jump right into the coding. And the first thing is we need to get some documents onto our system. So some annual reports or 10K reports to work with. In my case here, I have the Meta 10K report and the NVIDIA 10K report. You can, of course, go with any company that you're interested in. How you find these annual reports is quite simple. You go to your favorite search engine, you type company name, provided that it's a public company, of course, and followed by investor relations or annual report or 10K. I assume most of you guys watching this will already know how to get these documents. By the way, everything we do today can also be applied to any other document, any other PDF document here, as long as it's a format that is well known. So quarterly reports are also fine. Maybe you have to adjust the data model depending on the document if certain fields are missing. But in general, this is not exclusive to annual reports. This approach can be done with all sorts of files that you're interested in. So in the case of Meta here, if you type Meta investor relations or Meta annual report, you're going to be taken to that page. You can go down here to the SEC filings and you can see the 10K annual report. You can download it here as a PDF. In the case of NVIDIA, you get to this page. You can download it from here. And again, for any other company, just type company name, annual report, and you're going to be taken to their investor relations page. Now, in addition to that, we also need an API key for our language model. In this case, I'm going to use the Google API, so I'm going to use Gemini. You can, of course, also use OpenAI or Mistral. The important thing is you need to pick a provider that offers structured output so that it can handle pydantic models. In the case of Gemini, that's possible. So what you want to do is you want to go to the aistudio.google.com/app/API key page. You will find a link to it in the description down below. And you want to create an API key if you don't have one. Now, keep in mind here that there is a free tier. So you can use the Gemini API directly and not pay anything. I think I'm blocking this now. So let me zoom out a little bit. So you can see here I have a free tier here. I also have a paid plan, which is for an actual project I'm working on. But in the case of just playing around with it, you can go with the free tier. You don't pay anything. You can just copy the API key from here and use it in your project. So go to this page, create an account, create an API key up here if you don't have one. Make sure you're using the free tier so you don't have to pay anything. And then you can just use this API key for the structured output. So how do we do that? We go to our working directory and we create a file called .env. Now, in my case, this file already exists. I already have my API key in here, so I'm not going to show it, but I'm going to open up a alternative file, which I'm going to call .env.tutorial, whatever. This is basically, in your case, just .env. I'm just showing you what to put in here. What you want to put in here is Gemini underscore API underscore key is equal to, and then in quotation marks like this, the API key that you copy from Google. You want to save that as .env, not .env.tutorial, .env. And this is what we're going to load into Python. Speaking of Python, we now need to talk about the packages that we're going to use. For this, now you have two options. You can just go the basic default way of using pip. So you can say pip or pip3 install, followed by the package name. So you can go with, in this case, we're going to use Google-GenAI. We're going to use Pydantic. We're going to use Python-.env. We're going to use tick token. This is optional if you want to count the tokens to estimate cost, provided that you're not using just a free tier all the time. And then also we're going to install Markdown 2 for the PDF and Wheezy print to easily work with Markdown or with HTML in this case. So these would be the packages that we install. You can do that with pip, or what you can also do if you already have it set up on your system is you can use UV. So if you don't have UV and you want to use it, you can say pip3 install UV, and then you can just use UV, which is the modern way of installing packages in Python. Both is fine. You don't have to use UV if you don't want to. Just use pip3 install whatever package you have. And then alternatively, you can go with UV init, the current directory here, and then I can just say UV add, and then the same packages. So again, let's type them out. There you go. And now I can just say UV add all of that, and we're done. That's why you use UV, because it's super fast. And now we can just open up this created main.py file. And we can, first of all, I want to show you, actually, maybe let's create another script in addition to that. We're going to create a script called counter.py. This is optional. You don't have to do that. This is just if you want to estimate how much how many tokens you're going to use for this. So what you can do here, by the way, I forgot one package that is important. So let me go back here. We also need PyPDF2 for the PDF extraction. So that's also a package you want to install if you used pip3 install, or pip install PyPDF2. So let us now create the counter.py file. This is optional, as I said, so it's not part of the extraction process. But usually when you look at API cost, API pricing, you have something like $1 or $10 or 50 cents, whatever, per 1 million input tokens. So you want to know how much money this is going to take you, because an annual report, as we saw, can be quite comprehensive, can have many characters, many words, many tokens. And you want to have some estimation of how much is this going to cost me if I have a credit card connected. And if you're building some product around this, of course, you will have a paid tier, not just a free tier. So this is what you can use this helper script for, but this is again optional. What we do here is we import tick token, we import PyPDF2, and tick token is actually for GPT. So the token estimation is for OpenAI, but it's not going to be too radically different from Gemini. So to get a rough estimation, it's fine, I guess. And we're going to say here, load file given some path. We're going to open this path or open the file. So with open path in reading bytes mode, SF, we're going to say that we want to create a reader. The reader is pypdf2.pdf reader. And of course, given the file pointer f. And then we're going to extract the text. We're going to say return empty string dot join, and we're going to extract, or we're going to combine the individual chunks that were extracted, so, or the individual pages. So page extract text or nothing for page in reader dot pages. That is our load file function, and then we're just going to say here text is equal to load file. In our case now meta 10k PDF, and we're going to say the encoded text, so tokenized, is going to be equal to tick token dot encoding for model is going to be GPT-4o. Again, we're using Gemini, but we're going to use GPT-4o. And then we're just going to say print length encoding or encoder dot encode text. So it's going to tokenize our text essentially, and it's going to count how many tokens we have. So you can run this once if you want to see the rough estimation here. So, obviously we need to do, since we're using UV, we need to do UV run counter.py. So this is going to take some time. It's going to load everything. It's going to tokenize it. It's going to count it, and probably around 100,000 tokens. Yeah, there you go. 112,103 tokens. So that would be 1/10 of the cost that is listed on the pricing page. Now we're using the free tier, so it doesn't really matter. But if you want to estimate it, you can do it like that for every file, of course. So let us now get into main PY, which is where the magic happens. Here now we're going to do the whole document extraction. So let us start with the imports. We're going to start by importing here OS. So these are the core Python packages now, or modules. Import OS, import JSON, from datetime import datetime, from typing import list and optional. Now let me explain briefly why we use that. We use OS to load environment variables. We use JSON to specify the schema in text. We use datetime and list and optional for Pydantic to define types of the individual fields. Then we're going to say again import PyPDF2. We're going to say from Google import GenAI. This is what we use to communicate with Gemini. Then we say from .env import load.env. This is going to load the environment variable for the API key from the .env file. Then we also need from Pydantic import base model and field. So the idea is we define the model using base model, and the field is what allows us to provide the description and default values and stuff like that. So mainly for description, we're going to use that. And then finally, from markdown to import markdown, and from Wheezy print import HTML, like this. This is now just for crafting the final report if you want to do that. Easy. So the whole magic is going to happen in our data model. We just first of all need to load the API key. So load.env is going to do the magic. And then we're going to also say, as we had it before, load file given a path. I'm just going to write this again. Or actually, I'm not going to write this again. We're going to just copy paste this here into this file. There you go. So the same as before, load file, path, open path, read bytes, create reader, extract every page, concatenate it or join it. And now we define our model. And this model is something you can customize exactly to your specific use cases. Maybe the only thing that you want to do is company name, officers, net income for every company that you're interested in. Then design your data model like this. Maybe you want to have 100 fields, 200 fields. Now, in the case of too many fields, I think you will need to do multiple requests and aggregate them, but you can completely customize this data model to whatever you want to do. So you can say here class annual report inherits from base model, and here now we can define all the fields. For example, company name, which is a string. So what we do is we define the field name, company name, the data type, it's a string, so it's text. And then we can also say equals, we don't have to do that, but we can do it, equals field dot, and then description is equal to, and here you can describe now to the model, to the large language model, you can describe what this is about. So the name of the company, for example. So the name of the company as reported in the 10K. That would be one field. And you can do that now with all sorts of different fields. You can say here net income, which is a float. You can also say it's an optional float. So it means that it doesn't have to be present, whereas the name would have to be present, for example. You can adjust this however you want. Now, I'm going to just copy paste this now here, and I'm going to go through the individual fields briefly, just because I don't want to spend now all the time here typing stuff that you're not interested in. But in this case, these are the fields that I chose. Take a look, take a moment to look at them. We have here the central index key, which is the identifier. We have the year end, the filing date, then some stuff here from the financials. So revenue, income, assets, liabilities, operating cash flow, cash and cash equivalents, number of employees, auditor, business description, which is a free field, a free text field, risk factors, management discussion, and you can choose here the different data types. You can see here for fiscal year end, I have date time. Date is not possible with Gemini. For the filing date, I also have date time. Here I have optional floats. I have an integer here for the number of employees because I'm not able to have like half an employee. And we can extend this with lists of things. So we can have an additional class here, maybe something like officer, base model, where we can say, okay, that is the officer name is a string, for example, and then you can have a list of officers. So you can say officers is equal to list of officer like this. And you can do that in a nested way. You can also define enums if you want to have only specific values possible. So all of this is up to you. Maybe you can even do something like an indicator. Is this a positive or a negative report? The intelligent model can do a lot of things for you. I wouldn't necessarily trust everything. By the way, none of this is financial advice. None of this here is investment advice. I wouldn't trust the output blindly, but I would just double check if everything's correct. That is now the basic data model that we're going to go with. You can extend this however you want. Once you have such a data model, we're going to create a client, which is a genai.client. And to this, we pass here now the API key, which is os.getEnvironment variable. So getenv Gemini API key. This is loaded from the environment, which again contains the key because we loaded it from the .env file. And then now we can say schema definition. This is only important because we need to provide it as a string to the model. I think for OpenAI, it's not necessary. I felt for some reason in the past that for Gemini it was. Maybe I'm wrong, but I like to do it like this. Schema definition is JSON dump into a string the following model annual report dot model JSON schema. So we take the Pydantic model, we turn it into a JSON schema. We take that, we turn it into a string using JSON dump s. We specify here indent is equal to 2. So the indentation is 2 spaces, a tab is 2 spaces. And ensure ASCII is false. So we take that, we have now the schema definition as a string, and then we can craft our prompt. We can say prompt is equal to a formatted string, analyze the following annual report 10K and fill the data model based on it. And here now we provide 2 line breaks, then the text. So we have the, actually we didn't load that. So let's say text is equal to load file meta 10K like this. So we have that, and we say text, then 2 line breaks again, and then we say prompt plus equals another formatted string. The output needs to follow the, or let's say needs to be in the following data format, line break, schema definition, line break, no extra fields allowed. That is our prompt. So we're requiring the prompt, we're instructing the prompt to follow this structure. However, this is just a request. It doesn't necessarily force the model to do that. If we want to do that, we need to use structured output. How do we do that? We do that by saying response is equal to client.models.generate content. Then we specify the model. Now, to keep it fast and simple, we're going to go with Gemini 2.0 Flash. You can also try 2.5 Flash or Pro if you want to. If this is really important to you, you probably want to go with 2.5 Pro. It's going to be the most competent one, but also the most expensive and the slowest one. So choose the model that you want to work with. Then contents is going to be equal to prompt. And then finally here, config. This is where the structured output happens. Config is going to be a dictionary. Response MIME type is going to be application/JSON. And now the important part, the response schema is going to be annual report, which is a Pydantic class. So that's exactly the class that we're passing here. And then the result is going to be, let's call it AR, is going to be equal to annual report dot model validate JSON response dot text. So it basically takes a text which is going to be in that format, it's parsing it into JSON, and we get the annual report object filled. So before we go into any of the PDF generation, we can just save this and we can run this uv run main.py. If you're not using UV, Python 3 main.py. Gonna take some time. Hopefully I didn't make any mistakes. By the way, one more thing that you can do to increase the quality of your results is you can use a different library for getting the text out of the PDF. So of course you can just use PyPDF2, but you can also use something like Mistral OCR or any alternative tool for that. That really extracts the structure as well, so that you actually have markdown and tables parsed correctly. That is definitely going to help. So you can see here the filled data model, company name, Meta Platforms Inc., then the identifier, the liabilities and revenue and net income and all that. So the next thing we need to do, or actually the last thing that we need to do here, is we need to take that and format it into a PDF document. So for that, we're going to go into the file again, and we're going to say markdown lines is equal to, and now we can pass a list, and we can just define the individual markdown lines. So I can start here with a heading of the largest size, and I can say ar.company name, and then I can say annual report summary. Then maybe here I can say AR fiscal year end, like this. And then I can add some more formatted strings. So I can say here in fat or in bold text, I want to say CIK is equal to AR.CIK. And then we can take the date. So for the year, so for the fiscal year end, I can say here in bold letters again, fiscal year end, also with a colon here, and then AR fiscal year end, like this. And then I can copy that. By the way, actually what makes sense here is to, in this case here, I'm just going to go with a year. So dot year, and here I want to format the date into a specific format. So I want to say here string format time strf time, and I'm going to provide the following string year dash month dash day, and we can now copy this and do the same thing for the filing date. So I can say here filing date, and the same formatting of the string. Now for the financials, since they are optional, we need to make sure that they actually exist before formatting them into Markdown. So we're going to do the following. We're going to say if AR.total revenue is not none. In this case, when it exists, we're going to take that and append it to the line. So MD lines is going to be equal to append formatted string, hyphen or bullet point, space, and then in bold characters here again, total revenue, colon, and then here dollar, curly brackets, AR.total revenue, 2 decimal places. That's that. And we can repeat this now for all optional fields. So I'm going to just copy paste this here from my prepared code. You will find all of the code on my GitHub, so you can copy paste and adjust it. But this is what this would look like. So net income is not none, net income, assets, liabilities, operating cash flow, cash equivalents. Now here for the number of employees, we don't have a $sign. And for the auditor, it's also just a string, so no $sign. Then we also want to have some major sections. So we're going to say if AR.business description is present, for example, we're going to say MD lines plus equals, because here we're going to have 2 things. First of all, a heading. Let's use 3 or let's use 2. And also a line break in the beginning. Business description. And then also the business description itself as text. Same thing goes for the risk factors. Here we need a list of bullet points. So AR risk factors. What we're going to do here is MD lines plus equals list and then \n risk factors. And here now we need bullet points. So we're going to have a list comprehension, which is going to be formatted strings that look like this, hyphen, and then the risk factors. So RF for RF in AR risk factors. So for each risk factor, we have a bullet point here, and these are just going to be combined then because we have here individual list items. This means that they're going to be line by line because we have MD lines and we're appending them all here as individual lines. Perfect. And then finally, we have if AR dot management discussion, if that is present, basically do the same thing as up here. So say management discussion, management discussion. That is how you craft that. So again, if you want to adjust this, you adjust the data model and you adjust this here. If you have some values that are optional, you check if they're there, if they're none, and you just render them into your markdown. If you have something that you want to iterate over, you use something like list comprehension. You define headings like this in markdown using hashtags. If you have hashtag just once, then it's the largest heading, and the more hashtags you use, up to 6, the smaller the heading is going to be. And once you have your structure ready, once you're done, you just say MD is equal to \n dot join MD lines, which means there's going to be 2 line breaks between all these lines, one to just go to a new line and another one to leave a blank line in between. Then we're going to say HTML is equal to markdown MD. So that is the HTML content. And now we're going to say company is equal to AR company name replace. In case we have any white spaces, we want to replace it with underscores because that is going to be relevant for our file name. I want to save it as annual report company name year and then .pdf. So we need that. And the file name is going to be crafted like this. It's going to be a formatted string, annual report company underscore and then AR fiscal year end .year .pdf. And finally, HTML string is equal to HTML .write PDF file name. So if I didn't make any mistakes, this should now work. I can just rerun the exact same script. Of course, I need to do it with UV. So UV run main.py. Oh, actually, I made a mistake when implementing the risk factors. We need to go to that line. And actually, here we don't use the comma. We add the 2 lists. Otherwise, we have lists in here, which is not good. So we need to do it like this, UV run main.py. And I have a typo, company is not company, so we need to change that as well. Here, company. There you go. So we have the output again here in the command line, but in addition to that, we should have an annual report, Meta Platforms Inc. 2024. So let's open up, in my case here, Nautilus in this directory and open this. There you go. Meta Platforms, all the metrics extracted, all the risk factors, and also the discussion. And again, none of this has to be 100% reliable. I assume with Gemini 2.0 Flash that most of this stuff will be accurate, but it's already good enough if you don't have to manually search for that information. If you can just go into your document and see, okay, I know that the liabilities look like this. I can still double check and see if that's true, but I can at least see, okay, does this make sense? Does this look in any way odd? Does it look in any way interesting? And then I can go into more details, or I can adjust my data model and extract more details. But this is, I think, a very useful tool for investors for making decisions. This can, of course, be customized. It can be made much more complex. We can turn this into an agentic system. We can, of course, also build a user interface around it. A lot of stuff can be done to improve this, but that's like the basic prototype that you can use to summarize annual reports and to extract information from them. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.